Today we will be learning about function notation, which looks like this. It's got an f and then an x in parentheses, and that is read as f of x. You may need to make that box a little bigger, but it is not f times x, it is f of x, and that is how you should say it. Equations can be written in a form called function notation, which is a way of renaming an equation by replacing y with f of x. So if, for example, you had an equation that was y equals 2x minus 3 and you wanted to write that in function notation, it would be f of x equals 2x minus 3. So same equation, but instead of a y equals, we're going to write f of x equals, and that is function notation. We view this as a quick way to evaluate functions for a given input for x value. F of a equals c is read as the function evaluated at a is c. So the input x is a, and the output y is c. So again, f of a is c, so that means the function evaluated at a is c. The thing in your parentheses is your input. So that's how you can remember it. If it's in the parentheses, it's your input. If it's outside of the parentheses, that's the output. So this is your x value, and this is your y value. Graph the following points on the coordinate plane. So the first one says f of 3 equals 4. So my input, my x value is 3, and my y value is 4. So that means it is the ordered pair 3, 4. So again, input, output, x, y. So I'm going to take point A and put that at 3, 4. So go over 3 for my x value, and my y value is 4, so up 1, 2, 3, 4. So we're looking at that point, and we're going to just put it as best as we can. It's a little hard to do with these, but that's close enough. All right, the next one, f of -2 is 1, so that means my input, my x value is -2, and my y value is 1. And we will take point B. We're going -2, so on the x-axis, go left to -2, and then go up a positive 1. And again, just get it as close as possible there. Next one. C, f of 0 equals -5. So that means my input is a 0, my x value is 0, and my y value is a -5. So to graph that, I go over 0, so I don't go over at all, and I go down to -5. So that is about there. Point D, f of -5 equals -6. So x is -5, and my output, my y value is -6. So that point is left, x value is -5, and then down to -6. So okay, finally got point D where I wanted it. If your points get messed up, if the boxes drag weird, you can always hit the undo button up at the top, right under file, and that can help. All right, and the last point, my input is 3 and my output is a 0. So 3, 0 means I'm going over 3 here, and then I don't go up or down, we just stay on the x-axis. All right, so I've graphed all the points. Let's go on to the next slide. To evaluate a function for a specific value, we are going to substitute that value in for x. Let's go ahead and pull out our paper and do these 4 problems. Question 1 tells us f of x equals 1/2 times 4x minus 6, and they're asking us to find f of 2. So remember, the value in the parentheses is your input, or your x. So this is telling us that x equals 2, and we want to evaluate that. So we are going to replace our x with a 2 and find out what f of 2 is. So we are going to write f of 2 equals 1/2 4 times 2 minus 6. And now we're going to solve. Now on the left, this is again not multiplication. We don't have to do anything with this. I'm just going to leave it as f of 2. And then over here, I'm going to follow my Noether order of operations. So I would do parentheses first and then multiplication. So I have 1/2 times 8 minus 6. Again, keep that first part. Next, I do my subtraction. So it becomes 1/2 of 8 minus 6 is 2. And then 1/2 of 2 is just 1. So this whole thing is my answer. So the nice thing about function notation is that it restates the question and the answer. So we've solved this problem and we can say, well, f of 2 is 1. If I put a 2 into the function, I get a 1 out. Second question says g of x equals x squared plus 3x. We want to find g of -2. As a note, this can be any letter we want. F of x gets used a lot, but you can do g of x, h of x, w of x. All letters are available. Another good thing about function notation is it does allow us to differentiate between different equations. If they were all y equals, it would be hard to tell them apart, but I know that this is a different function, different question than the last one, because this one's g of x and the last one was f of x. So again, that's my input. This is my x value. So I'm going to say that g of -2, if I put -2 into the function, I will have a -2 squared plus 3 times -2. And make sure you are using parentheses here. All right, again, I keep that first part because it's really just labeling my answer. Do my exponent, -2 squared, and it's in parentheses. Negative times a negative is +4 plus 3 times -2. I can do my multiplication. 3 times -2 would be -6. And then a 4 minus 6 is a -2. So that is my answer. G of -2 equals -2. If I put in a -2, I get a -2 out. We could also write this as an ordered pair. -2, -2. Next question, number 3. If h of x equals 6x minus 8 and h of x equals -4, what does x equal? So this is a different kind of question. They're not asking us to find the output. They've given us the output. We want to find the input. So do not put in -4 for x, because again, I don't know what x is. I want to find it. So since they've given us the output, what I'm going to do is replace my whole output, h of x, with -4. So -4 equals 6x minus 8, because I want to know what value of x will make this equal -4. And now I solve for x. I will add 8. -4 plus 8 is 4. Divide both sides by 6. And that's a fraction which I can reduce to 2/3. So the answer to the question is 2/3. And again, if you wanted to write that as an ordered pair, when x is 2/3, your y value or your output is -4. And the last one, similar question. If f of x equals 3x plus 2 and f of x equals 11, what does x equal? So I know the output, I'm trying to find the input. So I'm going to replace f of x with 11. And I will solve for x. So subtract 2, I get 9. divide by 3, and x equals 3.